In this lesson, we'll learn about the fundamentals of R.
In this video, we'll discuss what R programming is and its uses. We'll learn how to download and install R and RStudio. Then we'll familiarize ourselves with the interface of RStudio. We'll understand basic working etiquettes with R, such as creation of working directory, setting up and changing the working directory, creation of new projects and working with projects. We'll also learn installation of packages and adding them to the current working directory. Next, we'll talk about working with inbuilt functions in R. We'll also discuss about arithmetic and logical operators. Lastly, we'll discuss working with different data types in R, such as vectors. We'll also understand the construction of user-defined functions. The course will help set up a building block for learners and act as a platform to implement more complex tasks in advanced topics using R.
In this video, we'll discuss what R programming is and its uses. We'll learn how to download and install R and RStudio. Then we'll familiarize ourselves with the interface of RStudio. So we'll start with introduction of R and how to download and install it. R is an independent open source tool and offers free implementation. It is an extension of the S language. It has huge computing power. It is an essential tool when it comes to data science and research. A key advantage of R system is that it is free, it's easily downloadable and installed. And as we'll describe it shortly, it is easy to use. R is a statistical computing environment that includes an interpreter for the R programming language with which the user programmer can interact in a conversational manner. R is one of the several programming environments used to develop statistical applications. Others include Gauss, Julia, Python, Stata, etc. The best way to obtain R is by downloading it from the internet by simply looking for R project. And as we'll see, by just simply clicking on the relevant web page to download, it will mention all the country's name and their corresponding CRAN packages. We can check the link for India as well. On this link provided, we can download R. We can download the latest version available. R runs under all the commonly available computer operating systems like Windows, Mac OS, Linux, and Unix. And precompiled binary distributions of R are available for these systems. Once we have done our installation, we'll install RStudio. The link is shown here to download RStudio. RStudio is an interactive development environment IDE for R. Like R, RStudio is open source software freely available on the internet for Windows, Mac OS, Linux, and Unix systems. Regardless of our computing system, the user experience in RStudio is nearly identical. RStudio has excellent facilities for writing R programs and packages, but more to the point for us, it provides a convenient environment to conduct statistical data analysis. We can select RStudio and select the appropriate installer, which is appropriate for our operating system, and we can then start working with R. Let us have a look at these sources where we can download RStudio, and also there is a facility to directly work on R without installing it by clicking on R Cloud. In this video, we'll explore CRAN. Kindly have a look at this web page and this link, cran.rproject.org. On this web page, you have all the relevant information related to R is available. For example, you can see what is the latest news, what are the latest updates, what are the latest releases. Let's say you want to download the latest version of R for your operating system, maybe Linux, Mac OS, or Windows. You can click here on one of these links. Let's say if I have Windows, I can click on this download R with Windows. Here I will find the latest R for Windows system available. I can click on it and download it for the first time. Also, there are a lot of other functionalities. For example, if you want to download or have a look at the R journal, you can click on this R journal button and you will be taken to this page where all the new updates, new publications about our latest packages and everything will be available on this page. Similarly, if you want to see what are the latest happenings in R, what is the new news or those kind of things, you can click on what's new and you will be taken to this page. All the latest announcements related to R and other things will be available. Similarly, there are a lot of other manuals, FAQs, and other information. For example, if you want to specifically search something related to R, you can click on this R search, CRAN R search, and you'll be taken to this page where you can search something specific to R. Also, once you install R, you also need to install RStudio. So you need to go to this web page, rstudio.com, and here all the latest RStudio versions will be there. you'll be given the basic functionalities with free version, and also there are some advanced versions, and you'll be given a comparative view with these and along with the free version. In my experience, the free version provides all the capabilities and computing power, so you can download this free version here, or you can download it directly from here. Download RStudio for Windows if you want to. If you have some other operating system, you can download it for Mac OS or Ubuntu or other versions. The latest version is available here. You can download and install it. It's quite easy. Once you download R and R Studio, you are good to go. Although some of us may be using new device or may sometimes may be working where it is not installed, those kind of devices. So there also you have the option to go to this page, R Studio Cloud. On R Studio Cloud, you can directly work. You need to make a free account. So once you make your free account, R Studio Cloud, this kind of web page will open, and there you can directly start working. Although some limitations are there in terms of space and capacity and speed, there are some limitations, but still it will give you exactly the same interface and something similar in terms of basic computing power. It will offer you a lot of similarities with the actual installed R. So with this, there's a lot of flexibility and freedom working with R, whether you have installed on your device or you have not installed but you are working with R Cloud as well. Let us get familiarized with the interface of RStudio. When you start RStudio, you'll find a window like this, an interface, which is basically RStudio interface. The RStudio interface shown here is quite customizable. Right now you can see 4 panes here, and as you become familiar with it, you can very well decide to reconfigure these panes, basically the RStudio visual, as per your preferences. For example, you can move these tabs or different panes and change the placement of these panes to your liking. RStudio has 4 main panes, as you can see right now, each in a quadrant of our screen. This one is called source editor. This one is called, the lower one called console. Then this one is your history or workspace browser, and this one contains the plots, help, files, etc. So now we'll have an overview of all these 4 quadrants in brief. We'll start with this script editor, which is the top left pane. The source pane is where you create and edit our scripts, our collections of code. You'll notice that when you're typing code in a script here on this source panel, for example, codes like this or codes like this, R won't actually evaluate the code as we type. To have R actually evaluate our code, you need to first send the code to console. We can see in the next figure for our reference, to create and save an R script in the studio, you can go to this file button. Here you can do a lot of operations for the script and other operations. For example, you can save by clicking here, you can save the R script. You can open new R script, you can open existing R scripts and so on. Once a script or a file has opened, you can save the file by going to file save, so that can be done. You can keep the same name or you can change the name. Once you save, automatically the extension .r, which is basic syntax for R files, that is automatically added. If you have put a specific code, for example this 5 into 3, to run this specific code you can click on Control Enter, or you can go to this particular run point and click on this. Wherever the cursor is, that line will be run. You could also run a set of lines. For example, you can select a set of lines and then either click Control Enter or click on this run button and run the series of lines of codes. So this is about R script. Next, you also have something called console window, which is here on the left bottom. The console is the heart of R. This is the place where R actually evaluates the code. At the beginning of the console, you can see a character. This is basically a prompt. This prompt tells us that R is ready for new code. We can type the code directly into the console after the prompt and get an immediate response. For example, if I type 1 plus 1 here into the console and press enter, notice an output is produced. We'll see that R immediately has given us an output of 2. But generally it is preferred to write the code on the script and then run it. And later you would like to save it as well. So that is why it is better to write codes on script. Here you can, for practice, you can write directly and run, but you will not be able to see. If you want to clean this console, you can click on this broom button, or you can click or run Control plus L. So if you click on Control L or if you click on this broom button, all that is there in this console will be clean. Third is history or environment panel, this one on the right of top. The environment tab of this panel shows us the name of all the data objects that are right now there. So if there are any data objects, let's say I create a data object equal to 3, it will be put in this environment tab. So that means it is added to my current working environment. So all the vectors, matrices and data frames and other data objects that you have defined in the current session, they'll be appearing here. We can also see information like the number of observations and rows in a data object. So that also is visible here. The tab also has a few clickable options like import dataset. So you can click on this import dataset option, and different data types you can import by clicking on these from text, Excel and other softwares like SPSS, SAS and Stata. Also, once you click on this import dataset option, it will open a graphical user interface for importing data into R, as we have said. So you can click and input data. For example, if I click on text base and then I can click on, for example, this data file. So files like CSV file or text file can be read. I can click on this open button to read this. Once I click on open button, an overview of this data will be provided. Some options to change the format, for example, header, footer, whether I want to read it as a comma separated file or a period as decimal, comma, these kind of options. And it will give me a default picture also. And I can change it by clicking on some of these options. And to my liking, if the input data is to my convenient, I can click on import and it will be imported. And also a brief overview, the way data has been read, that is also shown to me here. So this is how the environment tab works. Here also you can see the history tab. All the commands that have been run till now, they are visible here. I can see them in the past, those commands that are run. If you want to clean this, you can click on this clean button, but be sure that all the everything that is there is needed has been used and you do not need the objects here. Then only you click on yes and everything will be removed from the current environment. But you need to be very sure that you do not need them further. You can also click on tutorial button to see some help and tutorials that are easily available on main R page. Now we'll go to the multi-purpose pane, which is on the bottom right. Here you can see file, plots, packages, these buttons, and also the help panel. So there's a lot of helpful information is also there. Let us go through these tabs in detail. First, you have Files tab. The Files panel gives you access to the files directly on your hard drive. There are a number of nice features on the Files panel. For example, you can use it to set your working directory. You can set working directory here. Or once you navigate to a folder, you want to read a file and save files, you can click more and then save as working directory. For example, if I want to read this davis.rds file, I can click on it. It will give me an option that should we read it. If you click on OK, it will be read and the name assigned to as David. Similarly, there are other files that you can read. Also here you can set working directory as well. In fact, you can set the working directory here by clicking on session button and then set working directory button. Here you can see choose directory. Once you click on choose directory, some window will be opened. If you want to set this particular folder as your working directory, you can click on open, or you can change here by going to some different folder. Once you click on open button, notice a setwd command has appeared. It is indicating where the current working directory has been set. And in that particular directory, what are the data, objects and other things that are appearing here on my file tab. Then look at the plot window. All the plots that you have currently plotted will be appearing, including some history of plots as well. There are buttons for opening the plot. So once you have made the plot, there'll be buttons for opening the plot in separate window, a larger window, or you can export it in the form of PDF. You can export it in the form of JPEG. You can change the size. You can do a lot of permutation and combinations with your plot to make it more aesthetic on this plot window, as we'll see shortly. Then you have a packages tab. Here is the list of all the available R packages that are installed on your current drive and indicates whether or not they are currently loaded. In this section, the package is unchecked, they are not installed. If it is checked, those are installed, but maybe not loaded. The checked package, the packages that are checked, they are both installed as well as loaded. If they are not checked, that means they are just installed but not loaded into your current working directory. So either you can just click on check like this and load them on current working directory, or what you can do is you can use something called library command and put the name. Let's say if I want to put a car package, it will provide me a drop down menu. I can select the car package and I can run with control enter command. Notice on the console window, the car package has been loaded now into my current working directory. So it is loaded now and I can start using it. Those that are not checked, those packages are though installed but not loaded in my current environment and I may not be able to use their functionalities. Last and another very important window is help window here. On this help menu, you have for different R functions, you can directly type here for help. For example, anything, maybe regression topic, any topic you will type, the relevant help will appear on this particular panel. There's another way. If you want to find help, you can put question mark, and let's say if you want to look at something about regression, you can directly type question mark and control enter. So if you have put the relevant and correct keyword, it will start appearing here. For example, I want to know there's some object called LM. I put control enter, all the information about that LM fitting linear models is appearing here. So either I can put on this space or I can put with question mark to access the help window. To summarize, in this video, we have tried to install and set up R and R Studio in our system. Also, we have understood a brief understanding of all the quadrants, all the 4 panes in the R Studio, and we will start doing basic coding in subsequent sessions. In the previous video, we have discussed how to install R and R Studio and have familiarized ourselves with the interface of R. In this video, we'll understand how to create a working directory and create projects in R. We'll also discuss installing and loading the packages and their use in R. First, we'll start with working directory in R. The working directory in R is the folder where we are working currently. It is a folder where R reads and saves files. If you want to change a working directory or set a new working directory, it can be done in the following steps. First, we'll go to this session command, session button, click on set working directory, then choose working directory, and then you can change the current folder, or if you want to have a particular suitable location. For example, I want to create my working directory here inside introduction, and in this particular folder I want to create a working directory. I can do so. For example, I'll set this working directory. I'll click open button. Notice a setwd command has appeared. You can very well copy paste this command into your current file, or you can leave it as it is. Once you have set your working directory, notice this file tab. Here, the current location is exactly the same that you have set as working directory. All the files, data, and everything that is there in that working directory is appearing here now. For example, you can directly load data from here or read data from here by clicking one of these data and code files. So now we have just through this step set our working directory where we wanted to. It is also possible to do this directly using the function setwd, which stands for set working directory. For Windows, the command would look something like this. Let me copy paste it for us. So notice the syntax of this command. You have the setwd command and the location or the address where we wanted to set our working directory. Though it is rather lengthy, you can have a small working directory location also where the address is not so lengthy. Setting a working directory is the best practice to help us store the coding data in a particular directory and remove the risk of remembering the directory location. So even after 6 to 9 months later, when you are working on this file, you need not remember where was the location where you saved the data and you were working. If you have copy pasted this code in that script itself, so if you copy paste this setwd line along with the location, you need not remember the exact location. Now everything that you write in the code will automatically be saved in that particular directory once you have set the working directory appropriately. And to know that it has actually happened, there is a file tab as we have seen here in the fourth window, the multipurpose pane, which shows the address of your current working directory where all the files under the working directory will appear. We can directly open the files from here by clicking on them on a particular file and click on import. For example, here I can click on the data files and import them. Now, if you want to know your current R working directory, just type the command getwd. So if I type the command getwd, it will produce the current working directory. This getwd stands for get working directory. If you want to set a default working directory, a default working directory is a folder where RStudio goes every time you open it. You can change it. You can change the default working directory from the RStudio menu. You can go to the tools, global options, and then you can click on browse and set your permanent working directory wherever you want to. So it will be the default directory every time you open R. Also, you can close your current RStudio session. Every time you close RStudio, you'll be asked whether you want to save the data. So if you click on this close button, you'll be asked to save your data from R. If you want to save, you can click on save you can check or uncheck whichever script files or working space files you want to save. You can click on save select. If you uncheck that, that file will not be saved and the older version will be only remaining. If you want to update it, you rather put save selected and check mark on all these files. So this is how you close your R and current working RStudio session. Next, another very important entity is projects in RStudio. So when you are working in projects, you want to save it, open old projects. Projects is a collection of script, data, intermediate outputs, and so on. So let's say in my current working directory, there is a project called macro. There are two ways to load this project. Either you directly click on it. Once you click on it, it will ask you whether you want to load it in your current working environment. If you click on yes, a load command will run, which will put all these codes, data, everything in that particular project on your current environment. Or you can do it through manually by coding. You can simply run load and give the name of the project, which is macro.data, macro.rdata, and it will load it automatically. So these are two ways to load the project. If you want to open it, you can directly open new project or open existing project in this session or new session. That way you can open it. You can also save the projects as well. So if you want to save a project, you can save the project as well. Projects in RStudio in R are means of organizing your work so that both you and your RStudio can keep track of all the files relevant to a particular activity. For example, a student may want to use R in several different projects, such as statistics course, a sociology course, or a thesis research project. Using RStudio projects to organize your work will keep the files for distinct activities separate from each other. To create a project, you can click on this file and then new project. To start a new project from RStudio menu, in the resulting sequence of dialog boxes, successively selecting existing directory or new directory depending upon whether or not the directory already exists. Let us understand about creating projects and working with packages in R. Using RStudio projects to organize your work will keep the files for distinct activities separate from each other. It is always advisable to save your work in the form of projects where you can save all the data files, codes, and other intermediate outputs. So let us see how to create new projects. Go to File, click on New Project. Now let's say you want to create a new directory, or you can also open in the existing directory if there is an existing project. Let's say you want to create a new project in new directory. You give it a name. Let's say we give it a name called new project. We create this project. This is our new project that we have just started. In this project, let's say we have some code files. Let's say we run some codes. These are some code files. Maybe from some other places I have this code file. I also have some output. Let's say I click on this macro data to load this on my current environment. I have now this macro data loaded, which I clicked here. By clicking here, I loaded this macro data on my environment. I also clicked on some of the codes like session 1 and opened the code. Now let's say I want to save them all together, the data, the code file and other things in the form of a project. To do that, what I need to do is I need to click on this new project button, and now I can close this project. It will ask me to save the project. I'll save it. Once I save this project, the project is saved in the directory called new project. In future, if you want to open this, you can go to File, you can click on Open Project, or you can directly check on recent projects where you have saved this file in the directory New Project. Once you click on that, all the codes, data files, everything will be loaded exactly in the manner when you were working, and you can use this in the manner you want. So this is how you create new projects, save new projects inside new working directories or existing working directories as well. Now we'll come to the packages. Packages is also a very important aspect of R codes. R comes with a lot of extensive capabilities that are right out of the box. Some of these most exciting features are available as optional modules that we can download and install. There are more than 5,500 user contributed modules called packages that we can download from the CRAN website that we saw earlier. We'll use many of these optional packages in this session. What are these packages? Packages are collections of R functions, data, and compiled code in a well-defined format. The directory where packages are stored on our computer is called the library. R comes with a standard set of packages, the base packages or datasets, utilities, graphics, and methods. These base packages provide a wide range of functions and datasets that are available by default. Other packages are available for download installation. Once installed, they must be loaded into the current session in order to be used. You can use the command search to tell you which packages are loaded and ready to use. To install a package for the first time, you go to this tool button, then click on install.packages. Window will appear. Here you can click the name of the relevant package. For example, if you want to name the package, let's say you want to download package car, you can select this package and drop from the drop down menu and then click on install. Once you click on install, the relevant package will be downloaded. Notice the console window, install.packages command is appearing. Now the CR package, once this is installed, the CR package car package will appear in your list of packages. I can search that very easily, CAR. Once I search that, you notice the car package is there, but still it is unchecked. The full form and all the details are available about this package here. It is called Companion to Applied Regression, this CR package. If you want to add it to your current working directory, you can check it. Once you check on it, it will be added to your current working library. Notice that in the console window, there is a library car command appearing. You can yourself straight away when you are working, and if you have already installed this car package, you can click on the library command and just click car, and straight away running this library car will also have the same effect of adding this car package to your current working directory. So not only one, you can install more than one packages. For example, you can go to the install package and add a number of packages. For example, you can add, let's say, dplyr, you can add lubridate, maybe stringer. So in this manner, you can keep on adding more and more packages. All these packages will be appearing. You can pack zoo and so on. Once I click on this and I click on install, notice a command with all these packages. Notice install.packages, all these packages together. It will be installing in my current R. All these 4 packages are installed. In future, if I want to install in some other system, I can straight away copy paste this command in my R Studio window, script window, and run it to have the same effect, to install all these packages. Once you install this, you can add them to your current working library by putting in the library command, maybe dplyr, run this command, and it will put the library, update the library with dplyr. You can also similarly add lubridate. All the packages that you have installed that are not part of base R package, they will be added to your current library. So in this manner, you can add many libraries that you need. So in this video, to summarize, we have learned how to set a working directory, create projects on our studio. We have also installed a number of packages and seen how to install the packages that we'll need for subsequent sessions for data analysis. And also we have added some of these packages to our current working library. In the previous video, we have got a brief understanding of creating a working directory and projects in R. Now we'll start with basic coding. Let us start with basic operators in R. An operator is a symbol that tells the compiler to perform specific mathematical or logical manipulations. In this video, we'll discuss several types of operators in our programming language and their usage. We'll start with arithmetic operators. Arithmetic operations in R include addition, subtraction, multiplication, and division. As these are binary operations, they need 2 operands. They are simple and similar to operations in any other programming language. The following illustration tells about arithmetic operation between 2 variables in R. So we'll start with arithmetic operators. A very simple operation would be an assignment operation where I assign a value of 3 to A and I press Ctrl Enter. If I want to see what is inside A, I can simply press A and Ctrl Enter to get the output, and the value inside A, which is 3, is printed. Similarly, I can create a new variable which is B and assign a value of 5 by this assignment operator that is equal to. I can press Ctrl Enter and generate the output like this. I can type B, press Ctrl Enter and generate the output. These are simple assignment operations. Similarly, I can perform addition as well. I can press A plus B, Ctrl Enter, and I get the summation, that is 8. So this is addition operation. Similarly, I can perform subtraction operation, B minus A, which is 2. Multiplication, 15. Or division as well. All these symbols, mathematical symbols, are quite common to our daily usage. So we are not new to these. Also, if you want to create exponential operator, that is a to the power b, you can do that. For example, this is 243, or let's say 2 to the power 3, or I can type 4 to the power 4, and very easily the output is produced. You can also put more complex operations like these. These are common arithmetic operators. In addition to the common arithmetic operators, the package in the standard R distribution include hundreds of functions, that is programs for mathematical operations, for manipulating data, for statistical data analysis, for making graphs, for working with files and other purposes. Functional arguments are values passed to functions, and these are specified within parentheses after the function name. Here's a quick review of logarithm function, which plays a key role in statistical data analysis. The basic way of doing logarithm in R is with the log function in the format of log, then the value, maybe 100, then the base at which we want it. This returns the logarithm of the value at the given base, which is 2 in this case. By default, this function produces a natural logarithm of value. To obtain the information about a function, we can press help function or directly press the question mark with the log. We'll get the help here. We can directly use this help tab here to obtain the help. Now, if you want to compute log, another way to do that is use this help log, and you'll get the help available in log. Now, let us say we want to see what is log function. We can press log, and with tab completion, all the similar functions with log format or log syntax will appear. Let us look at the first one, which is log, along with the syntax. The tab completion gives us the entire syntax. We need to just press tab and all the syntax will appear in front of us. It shows that we can type x, which is the value. We can also specify the base. If we do not specify the base, the default base is exp bracket 1, which is exponential or natural base. So let's say we start with a log of 9 at a base of 3, we get a value of 2. This is the basic logarithm function with 9 as the value and 3 as the base. The results are 2 because 9 is the square of 3. Similarly, I can type log and 5, which will give me the value of log 5 at a natural base, which is 1.609. I can also compute similarly multiple values like log of 100 at the base of 10, or another way to do this would be log 10, 100, and I'll get the logarithm of 100 at a base of 10. So here we have a comparison of the base 10 logarithms of 100 obtained by the basic logarithm function and its shortcut. For both cases, the answer is 2 because 100 is 10 squared. Next, we have logical operators. Logical operators are used to carry out Boolean operations like AND, OR, etc. Let's look at operators and their descriptions first, then we'll proceed with their implementation in R. A simple ampersand, this ampersand symbol is logical AND operation. Then this pipe operator, this is called pipe symbol, this is logical OR. So operators AND and OR perform element-wise operations producing results having length of the longer operand, and double ampersand and double pipe operator examine only the first element of the operand, resulting in a single length logical vector. The logical AND operator returns true if both the operands are true and returns false otherwise. For example, look at this 5 equal to 5. Now in this case, if I run this, the output would be produced as true because both left and RHS and LHS are 2. However, if I put left and right operands as 4 equal to 5, it will produce an output of false because one side is not equal to other side. Also, let's say I want to assign this true or false to another value like this. Here, I am assigning a value of true to the value of A, and now if I want to check what is inside A, I can run control enter on A and I'll get true because a true value is assigned to it. Notice that I can also reflect true with T and false with F. So for example, F would represent a value of false and R considers false as 0. So if I multiply this with 60 or any numerical, I'll get a value of 0. Similarly, true or T is considered as 1 by R, and therefore if I multiply it with a numeric value, let's say 60, then in that case, I will observe a value of 60. Similarly, I can also check greater than or equal to and similar other operations. For example, 5 greater than 2. Since this is true, I'll get a value of true. If I put a value of not equal, this explanatory operation this exclamation mark in front of equal to, this is not equal to. So if I check whether 4 is not equal to 5, this will give me a true value. Why? Because 4 is not equal to 5. So exclamation mark along with any symbol is reverse of that, that is opposite of that. So if it is attached to equal to sign, it is not equal to. Also, I can have greater than equal to sign. So if I apply 5 greater than equal to 4, this will be true because 5 is indeed greater than 4. So that greater than condition is satisfied. Similarly, if I want to check whether 3 is less than equal to 4, it will be true because 3 is less than 4. The logical OR pipe symbol returns the boolean value true if either or both operands are true and returns false otherwise. For example, if I put true and true, both of them are true, then I'll get a true because it is AND operator. So both of these conditions need to be true. Or I can represent that with T and T, which is true. Similarly, if I use false and true, this will give me a false because one of them is false. If I use true and false, I'll get a false. In this case, if I use true along with pipe operator, I'll get true because one of the condition is true. Similarly, I can test multiple conditions. For example, I can test true along with another true and another true. In this case, since all the three are true, I'll get a true. If one of them is false, let's say I use T and F and T, so one of them is false, so I should get a false. However, if I was using OR operation, that is pipe symbol, and one of them was false, then even in that case I would have got a value of true because at least one of them is true. In fact, if I only one of the value was true and all of them were false, I would still get a value of true. To summarize, in this video we have learned the use of arithmetic, relational and logical operations in R. This strengthens our fundamental understanding of R and will be helpful throughout our journey with R. Now let us start with working with vectors. In this video, we'll discuss about vectors, a basic data structure that plays an essential role in our programming. We'll learn vector creation, vector manipulation, vector element recycling, vector element sorting, and indexing vectors in R. A simple way to construct a vector in R is with C operation like this. We start with vector creation. A simple way to create a vector in R with this syntax, which combines its elements. Many other functions also return vectors as results. For example, the sequence operator generates consecutive whole numbers, while the sequence function seq, this seq function does much the same but more flexibly. We'll discuss all of them one by one. So first, we'll start by creating a vector using this function. So we can write this C 1, 2, 3, 4. This will combine all the 4 elements and create a new vector with 4 elements 1, 2, 3, 4 as we can see in the console by running Control Enter. Now I can assign these values or this vector and give it a name, let's say V. If I run this command C, 1, 2, 3, 4 and assign it to a vector named V, the new vector V will be created, and if I run Control Enter, it will carry all the 4 elements. In this way, I can create an assignment operation by assigning a vector and giving it a name. If you want to see some initial elements of this vector, you can use head command and type head V. Similarly, if you type tail command, you get some of the last elements. But in this case, since the vector length is very small, it's only 4, then we are getting all the elements. In R, vector is a very important data class. A vector can be of numeric character or factor in nature, and as we'll see, we'll try to understand the nature of all these different kinds of vectors. You can also create multiple elements in a vector. You can use colon operator with numeric data to create sequences. For example, if you write 5 colon 13, it will create a sequence from 5 to 13. We can assign this sequence to a new vector called v1 like this. So the sequence is assigned to a variable named v1. A new vector v1 is created. I can type v1 and then Control Enter to see all the elements inside it. If the final element specified does not belong to the sequence, then it is discarded. For example, let's look at this operation. V equal to 3.8 to 11.4, and let's see what is inside this variable v, and you can see that a vector from 3.8 sequence to 4.8, 5.8 and so on is created, and it goes up to 10.8. The final element is discarded. We can also use an seq operator to create a sequence. For example, if you want to create a sequence from 5 to 9 by incrementing it with 0.4, I can write a function like this, seq, and then specify the starting point 5, ending point 9, and then I can specify the space or the increments, that is 0.4. If I run or press Ctrl Enter, you notice it starts from 5, then 5.4, then 5.8. So there are increments of 0.4 up till 9. This way I can create even non-integer sequence. Another example would be seq sequence command 0, starting point 1, and then I can specify the interval, which is 0.1. So it will create a sequence with an interval of 0.1 starting from 0 ending at 1. I can also, instead of specifying the increments, I can specify the number of elements in that. For example, I can specify the sequence command starting from 0 ending at 1, and I can specify the length of this sequence as 11. Let's look at the output. So it has produced 11 numbers in the sequence, a sequence of 11 numbers, and automatically distributed them with a gap of 0.1, which is derived from the length of the sequence. Next, we move to vector manipulation. In R, two vectors of same length can be added, subtracted, multiplied, or divided, giving the result as a vector output. Let us understand with a simple example. Let's create two vectors. First vector v1 using combine operator C and 3, 8, 4, 5, 0, 11. So we have assigned a certain element to it. We are combining them and giving them a name v1. Then we will create a vector v2 and give it certain names starting from 4, 11, 0, 8, 1, 2. We'll give it the name v2. Now I can perform a vector addition operation, and similarly notice each element is added one by one. For example, first element is added 4 plus 3, 7, second element 11 plus 8, 19, and so on so forth up till the last element, which is 11 plus 2, which is 13. Similarly, I can perform vector subtraction by simply writing v1 minus v2, and each element, its position by position, will be subtracted, that is 3 minus 4 minus 1, 8 minus 11 minus 3, and so on up to 11 minus 2, which is 9. Similarly, I can perform vector multiplication v1 into v2, and again they will be multiplied. Look at each corresponding position, that is 4 by 3, which is 12, 11 into 8, which is equal to 88, and so on up till 11 into 2, which is 22. There is also something called vector element recycling. What is this? In vector recycling, if we apply arithmetic operations to two vectors of unequal length, then the elements of the shorter vector are recycled to complete the operation. For example, I create two vectors of unequal length. Vector 1 has larger number of elements. For example, it has 3, 8, 4, 5, 0, 11. So it has 6 elements. Now I create another vector, give it a name v2, and only 2 elements inside it, 4, 11. Now if I perform a subtraction, let's say v1 plus v2, notice that there is no error message. Instead, R has created or recognized v2 as a variable which is 4, 11. It has automatically given it a length of 6, which is matching the length of v1 by replicating the sequence like this. So in this manner, it has created 11 elements so that the vector operation is completed. Similarly, a number of operations can be done. For example, another similar demonstration can be like this. I create 4 elements here, and then I create another vector but with only 3 elements. And if I perform the addition operation, I do not get an error message, but instead I get a warning message. But still the operation is performed. And notice the first 3 elements are 5 and the fourth element is 8. That means the third element, that is this, if you notice, the first element is again recycled to add to the last element of the first vector, which is 4, and therefore 4 plus 4 is 8. Note that if the operands are of different lengths, then the shorter version of the 2 is extended by repetition, as in this case, which was v1 plus v2 above here, where elements in v2 are 2, which is effectively repeated 4 times. If the length of the longer operand is not a multiple of the length of the shorter one, then also a warning message is printed. Next, we can also perform vector sorting. So we can perform vector element sorting. So elements in a vector can be sorted using sort function. So let's say we create a new vector v with these elements 3, 8, 4, 5, 0, 11, -9 and 304. So if I run this sort function, sort v, the elements are sorted from lower to higher. I can also sort them in opposite manner, that is putting v, and I can put decreasing. Instead of increasing, it will be generating a sequence of decreasing number. Similarly, I can create color. Let's put red, blue, yellow, violet, and I need to give the name, so I'll create combination C. Now these are assigned to a vector called color. Now if I press sort color, notice the color are sorted according to their alphabetical sequence. So B, R, V, Y. Next we'll move to indexing the vectors. So we'll start with indexing of the vectors. If we wish perhaps to print only one of the vector elements, we can exactly index or specify the location of the element within the square brackets. For example, we had created earlier a vector called v, and if you want to only print the third element inside that vector, I can run v3. This will print the third element in that vector. So in this manner, we can also specify a vector of indices. For example, v3 to 6, I can specify these 4 elements from their location starting from 3 up till 6. We can also specify a selected few elements. For example, let's say with this, I can specify first, third and fifth element. So I provided the location of first, third and fifth element, which is 3, 4 and 0 only. If I want to exclude a certain elements, I can also put a minus symbol which will specify or tell R that it needs to exclude these elements. For example, with this, I can exclude the elements number 5 and 7. So if I print now, all the elements will be printed except the elements number 5 and 7. To conclude, to summarize, we have learned how to create and manipulate vectors in R in this video. We have also discussed vector manipulation using vector element recycling when vectors are of unequal length. We have also learned how to sort the vector elements and print specific elements of a vector. Now let's look at data types and user-defined functions in R. To make the best use of R language, we need a strong understanding of the basic data types and data structures and how to operate on them. Each variable or vector in R is associated with specific data type. In this video, we'll be discussing all the data types and how to check them in R. We'll also learn how to create a user-defined function in R. R has 5 basic data types, that is numeric, character, integer, factor and logical data types. We'll first define all types of data structures and then we'll see how to check it in R. We start with numeric data type. Decimal values are called numeric in R. It is the default data type for numbers in R. Character data type. R supports character data types where we have all the alphabets and special characters. It stores character values or string values. Then we have logical data type. R has logical data types that take either a value of true or false. A logical value is often created via a comparison between variables. Integer data type. R supports integer data types which are the set of all integers. We also have factor variables, that is categorical variables like male, female categories. We can create as well as convert a value into different data types using functions like, for example, you can use add.integer to convert to integer. Or similarly, you can use as.character, for example, as.character to convert to character, maybe a numeric or integer to a character. Similarly, you can use as.factor to convert into factors, which is a categorical variable. So we start discussing about data types in R. First, let us illustrate numeric data type. We assign a numeric value to a variable named y. If I want to check the class of this new variable y, let us use the class command, and notice R has automatically recognized this variable as a numeric variable. I could have also checked the class of variable, or rather a vector, where 2 elements within quotes presented like this. Please notice now these variables or values are input in terms of in between quotes, and therefore they are recognized as characters by R. So we are forcing R to recognize these values which are originally integers, but we are forcing R to recognize them as characters. Then I can assign a value of 4 to X variable. I can assign a value of 3 to Y variable. And I can create a logical variable by checking whether X is greater than Y and assign it to Z. Here the value of Z would be true, of course, because X is greater than Y. And if I want to check the class of Z, let's see that. Class of Z is logical, which means it's a logical variable. Let's create a new variable. Let's create a vector of characters. This is v2 equal to c, and I will put 4 elements here. My, another element is name, next element is another element is Abhinava. So the character vector has 4 elements, that is my name is Abhinav. And if I want to check the class of this variable v2, I can do that. I need to assign that. See the class of this vector, it's a character vector. Along with finding the class, we can also find some more features about vector like number of characters, structure, and overall summary of vector or variable using the following codes. For example, I can summarize this variable or vector v2. Notice it shows that it has 4 elements. My name is Abhinav. Also, I can find the number of characters using nchar command, and it shows me that for all the elements, first element has 2 characters, second element has 4 characters, and so on. I can also deal with factor variables in R. Factor in R is a variable that is used to categorize and store the data, having a limited number of different categories. Factor in R is like a categorical variable that stores both string and integer values as levels. For example, let's look at this character vector here, which has a set of elements male, female, female, male, and so on. So it has set of number of elements written as male, female, female, male, and so on. Now, if I assign this character vector into a new variable called v5, which is a character vector, and I tell R that use this as a factor, not as a character vector. So I will assign this character vector in the form of a factor. And now that R has recognized this variable, this vector as a factor, I can check the class of this variable. This is coming as factor. If you want to check the levels of this factor, you can simply type v5, and for a factor variable, R will put the elements along with the categories as levels, which as we can see here is F and M representing female and male. You can also summarize, like we have been summarizing other variables, you can summarize this v5. Notice it is showing me that there are 6 elements in female category and 6 elements in male category. So this is how you summarize and understand the factor variable in R. Let's discuss user defined functions in R. As we have probably guessed, R includes functions for calculating many common statistical summaries such as mean of the numeric vector. Let's consider a simple variable x and assign a number of values to it. So we are assigning a set of values to this vector x. Now, if you want to compute the mean of this vector, you can simply use an inbuilt function called mean, which is 14. If there were no mean functions, we would nevertheless have calculated the mean straightforwardly using the built-in sum and length functions like this. For example, I could have computed sum of x and divided it by the length of x. Thus, I would have obtained the mean of this, where the length function returns the number of elements in its argument. To do this repeatedly every time we need to compute the mean of a numeric vector would be inconvenient. And so, in the absence of a standard mean function, we could define our own mean function like this. Here, this mean function would compute the mean of the argument x. Now notice you need not necessarily put x here, you can put y also. This is just a simple argument that needs to be fed in this function. So I can run this. Now compute this function for the variable x, and we again get the mean of x. So our function myMean here is used in the same way as a standard R element inbuilt function, and we can consequently use it in defining other functions as well. For example, the R function standard deviation can compute the standard deviation of a numeric vector. Here's a simple substitute for this SD function, which is my SD function, and let's use myMean to support this. So we'll create a new mysd function which will be a substitute to sd function, which is sd, this function. This is the original R built function. We'll create our own user defined function like this, and we'll use an argument z, and we'll supply some of the arguments here, square root. Now we need to create sum of x minus my. Now here we'll make use of myMean function, myMean of x raised to the power 2 divided by length x minus 1. So this is my SD function, and we can run this function. Now I can compute the standard deviation of this x variable 8.52. We could have simply computed the standard deviation of this variable like this as well, and we would have got the same values. So now we have created this user defined function which can be used to compute standard deviation as a substitute of SD function. Next, we move to conditional statements in R. Conditional expressions are expressions that perform different computations or actions depending on whether a predefined Boolean condition is true or false. Conditional statements include if-else statements, if-else separately, or a combination of them. Let's see the implementation in R. We'll start with a simple if-else function. The if-else function evaluates both expressions, expression 1 and expression 2, and then returns the appropriate values from each based on the element by element value of the condition. If an element passes the condition as true, then if-else statement returns the corresponding value of expression 1, otherwise it returns for expression 2. So the basic syntax for this is like this. You have if-else, first you provide the condition. If the condition is true, then expression 1 will be evaluated. If condition is false, then expression 2 would be evaluated. How do we implement it? Let's define a variable called gender, and it's a categorical variable, so we'll put certain male and female elements inside. So we'll put certain elements inside this gender vector. Now that we have assigned these values to our gender vector, what we'll do is we'll check which of these values are male or female, and for that we'll use our if-else function, and we'll check whether the value of gender is male. In case it is male, then we'll print M. If it is female, then we'll print F. So if I run this function, notice for each M and F, male and female, we have MF as printed there. What is the length of this gender variable? We can use length function to get the length, which is 12. Now we'll make use of for loop to print each element of this gender variable. We can easily make use of this for loop. The syntax of the for loop goes like this. You type for, and it will have the same effect. Notice I in 1 to length of gender. So we'll run as many times as the length of this variable gender. Then again inside this we'll put if else loop, and now we'll put gender and we'll put subscript I, so that every time this I counter changes, the value of gender moves from one element to next, and again we'll put the same condition male to check each element one by one. If it is male, it should print M. If it is female, the expression 2, which is here print F, should be executed. So now we'll run our for loop and see the output. And notice every time the counter is run, starting from I1 to 12, since we have put it to end at length of gender, which is 12, so 12 times the loop will run, and every time it will compare the value of gender with whether it is male. If it is male, the first expression will be executed, it will print M, and if it is false, then second expression, which is print F, so F will be printed if it is female. So now we have discussed one example of a simple if-else statement and one example of a for loop. We'll also discuss some advanced conditional comments in detail in the next module under data handling section in R. To summarize, we have learned how to quickly check the class of a vector or variable in R. We have also seen how R facilitates us to create user-defined functions and smoothens further calculations. We have seen some basic conditional statements, if-else and for loop, and we'll gradually move to the advanced part in subsequent sessions for data analytics.
To summarize, in this video, the learners are familiarized and initiated with our platform. After completing this lesson, learners will be able to create a new project and write basic codes such as simple mathematical and logical operations. Learners will be able to create new and different types of data objects such as vectors. The learners will also be able to create user-defined functions and automate basic mathematical and logical tasks. These topics will help learners and act as building blocks in implementing tasks and assignments pertaining to more advanced topics such as predictive analytics using R programming. In the next lesson, we'll discuss the types of data science projects and their life cycle.